Hi guys, my name is Didi Jimenez, and in today's presentation, I am going to go over Frank Starling's Law of the Heart. Have you ever wondered if the length of cardiac muscle fibers differ before contraction? Before contraction, the length of skeletal muscle can vary depending on the attachment position of the skeletal parts to the muscle. But in our case, cardiac muscle isn't attached to any bones. So what determines their length? The degree of diastolic filling is the main determinant of cardiac muscle fiber length. The book actually used an awesome example, and it was to picture a balloon. The more you fill the balloon, the bigger it gets, the bigger it expands. This fits perfectly into our diastolic filling. The more amount of filling, the greater the EDV, which is the end diastolic volume, and the larger the heart is stretched. With this, we get a result of a longer cardiac fibers before contraction. Now, it is important to note that longer fibers result in a bigger force being emitted on the subsequent cardiac contraction. With this greater force comes a greater SV, stroke volume. This intrinsic relationship between EDV and SV gives us the main topic of the presentation, the Frank Starling Law of the Heart. This law gives us the common normally pumping heart that pumps out during systole and vice versa. During diastole, the volume of blood is returned. It should be duly noted that an increased SV is a result of an increase in venous return. In our picture here, taken from the book, we can see how the length of cardiac muscle fibers depends on the extent of venous filling. This venous filling, as seen in the diagram, is usually less than the optimal length for reaching tension maximum. This means that increasing venous return, aka EDV, is done through moving the length of the muscle fiber closer to optimal length, resulting in an increase of contractile tension of the cardiac muscle fibers on the following systole. With this being said, more blood is squeezed out with greater contraction, meaning that as the heart receives more blood and EDV increases, a corresponding larger SV is automatically pumped by the heart. Okay, so why is all this important? As research continues, it has never become more evident that activated calcium ions cause a response in sarcomere length-induced changes in cardiac contractile proteins, which plays an important role in the topic of this presentation, Frank Starling Law of the Heart phenomenon. The mechanism to this is unknown, but the following study shows a correlation to the giant protein titin. In this study, myocardium from rats expressing a giant splice of titin were isolated and stretched. Looking at the pictures here to the left, we are given the twitch force of the two types of rats and their myocardium. As we can see, the stretching of the muscle caused an increase in passive and active twitch force. On the top right, we have an M2 cluster of peak intensities. As labeled in the diagram, 2 of the 5 Gaussian peaks can be labeled as C2 doublet peaks for myosin-binding proteins, specifically C. Now that we just received the meat and the information, we can conclude that these rats had massive amounts of giant titin. In conclusion, these rats that had massive amounts of giant titin isoforms had their cardiac muscles isolated, and we noted increases due to stretching that were shown by X-rays and demonstrated that, with the X-rays demonstrating increased intensities and periodicity of several myosin and troponin reflections. Not only this, but the radius of cross bridges also showed a significant decrease. With such results, there was proof that the hypothesis initially stated was not accurate and was ruled out. Unfortunately, with this being said, clearly there needs to be more studies done on the topic in order to find out the mechanism of the great phenomenon as to how the Frank Starling Law of the... Unfortunately, we have reached the end of the presentation. The article that was used is the top one mentioned. The bottom is a citation of the book, in case you want to look into this topic more. Thank you guys, and I will see you on the next one.